Data science, in some sense, it's only now maybe 2-3 years where we are seeing courses being offered, right? Till then, I think the discipline was not officially defined, and I really see it as an amalgamation of multiple disciplines. If I had to really boil down, maybe applied math and programming are the two fundamental building blocks, and then obviously you go deeper and kind of approach the same problem from multiple disciplines. So there's statistics, there's computational statistics, there's mathematics, there's operations research, there is game theory, all of that. So it's kind of an amalgamation of multiple disciplines. But if your background in maths is solid and you are able to kind of formulate a business problem into a math problem and you're able to kind of code it out, I think that should be good enough to get you going in the space.
Hello everyone, welcome to the Startup Operator podcast. I'm Roshan Karyappa. Over the years, data science has gotten out of the labs and R&D organizations to become an integral function at hypergrowth startups. It's a significant competitive advantage if you can get it right. But that is also an extremely challenging task. On this episode, I speak to Deepak Warrier, who is the chief data scientist at BlackBuck, which is transforming logistics and trucking in India. Deepak is a data science veteran with over 18 years' experience across companies like American Airlines, Citi, Myntra and Hike before he joined BlackBuck. In this conversation, Deepak speaks about what it takes to set up a data science function and how it can impact business and ROI. We haven't had a data scientist on the podcast earlier, so it was a unique opportunity for me to get to know this function that is becoming increasingly relevant. I'm sure you'll find this insightful. So let's get started on this episode of the Startup Operator podcast with Deepak Warrior. Hey Deepak, welcome to the Startup Operator podcast. Thank you so much for making the time.
Thanks, Roshan. Wonderful to be part of this. Looking forward.
Yeah, no, I really appreciate that. And, data science is one of those functions that I think, everyone wants it, but nobody is quite sure, where to get started. So I'm looking to cover a lot of the nuances of the function and, talk about your journey as well. Actually, let's begin with that. You've worked in data science for over 15 years now. What has that journey been like? And what would you say are some of those prerequisite skills to being a good data scientist?
Cool, Roshan, to be honest, if only I knew how big a deal this was going to be, right? Data science, AI, machine learning, 15 years, 17 years ago when I started, I've probably been more prepared. The journey of this space has been quite surreal. When I started 2005 and I finished my PhD was in optimization. I started working at American Airlines. At that time, the word data science did not exist. We were still solving hard problems, right? So not to get this wrong, we are solving hard computational problems like big scale crew scheduling, weather disruption management. But to be honest, that data science as a word was not articulated, right? And AI was also kind of restricted to labs, probably in universities, right? It was not as prevalent, right? Probably until the internet economy happened, right? And with concerts, auctions, and all of that, driving billions of dollars for the big tech. That's probably when the space kind of blossomed in some sense. And since then, I think it has been just jumping from strength to strength, right? And the last 10 years, and so both from the advent of and the growth of the tech companies as well as the advent of certain specializations in ML like deep learning, really breaking boundaries. I think this has just become very, very strong, right? And now, it's not only very prevalent in most companies, tech companies driving true ROI, and also problems which were like fundamental, a few years ago, we are seeing huge leaps, right? Via deep learning, machine learning, right? So I think this journey has been quite interesting, right? Starting from optimization and going into ML and going into deep learning and all of that, right? So that's, I think, pretty much what I'll have to say right now.
Right. What kind of a person do you think will make a good data scientist? What are some intrinsic skills aside from being good at math or statistics or doing a course or having certain coding skills like Python or whatever, right? What are some intrinsic skills that make for a good?
See, this is really, again, the discipline has not been defined, right? Data science, in some sense, it's only now maybe 2-3 years where we are seeing courses being offered, right? Till then, I think the discipline was not officially defined, and I really see it as an amalgamation of multiple disciplines, right? There's not one thing, right? Fundamentally, I think if I had to really boil down, maybe applied math and programming are the two fundamental building blocks, and then obviously you go deeper and kind of approach the same problem from multiple disciplines. So there's statistics, there's computational statistics, there's mathematics, there is operations research, there is game theory, all of that. So it's kind of an amalgamation of multiple disciplines. But if your background in maths is solid and you are able to kind of formulate a business problem into a math problem and you're able to kind of code it out, I think that should be good enough to get you going in the space.
Right. So you should be able to think in mathematical terms.
Can you abstract the business problem into a math formulation in some sense?
Right. Data science, as you pointed out, right, I mean, has gone from something fancy, something that was confined to a larger tech or R&D organizations, to today being a competitive advantage for literally every company, right? In the internet age or the data age, there's such a preponderance of data points that, every startup or every product picks up. What are some key inflections that you've seen over the last 15 years that has made this evolution possible?
So I think, as I said, the internet economy probably has been one inflection point, right, where we really saw the big data, volumes of data coming in, right. So that's one. You really need large data to be able to deploy advanced machine learning algorithms, right. The second thing is around 2012 is when we really saw, the next inflection point with deep learning models coming into the picture, right. Being able to solve fundamental cognition problems and using computer vision, NLP, and all of that coming into the picture, we could see this another transition, another inflection point. Right? That's being supported primarily by good computing hardware improvements in that, and these two probably two are big inflection points as influential in taking data science, machine learning into the next orbit in some sense, right? And if you really think about it, we used to, as I mentioned, when we were doing it, American Airlines, we were doing weather disruption problems, crew scheduling problems. These are large, computationally challenging problems, but the paradigm was slightly different, right? Here, you're trying to learn from past experience in some sense. That's how you would technically define machine learning. You're trying to develop a program using past experience and historical data, right? I think that paradigm is very well refined and articulated now, and primarily because of these two fundamental changes, I would kind of attribute to.
Right. So you've done multiple stints over the last 15 years, right? I mean, you've been at Myntra, you've been at Hike, and then now you're at BlackBuck. What is the nature of problems that you typically solve as a data scientist, right? I mean, help us sort of visualize what a typical problem is like. Right, and how has that changed over the years? For instance, has it gone from being very much optimization driven to being sort of a little more predictive, or are there any other facets to these problems that you see over the years?
I think a couple of ways to think about it. One way is, the fundamental approach has been same, I would say. What are we trying to build in a business context? We are trying to build data and algorithm driven decision making systems. That's probably the umbrella overarching theme, right? And that hasn't changed in some sense, right? For example, in the context of transportation, I think transportation was one of the earlier adopters. Even 12 years back, you would see all of these algorithms being deployed in airlines, transportation logistics domain, right? I think to now also what we are trying to do is, can we create intelligent decision making machines, right? Having said that, it changes quite a lot, right? From domain to domain, from problem to problem. But the overarching theme would be, I would say, there's some amount of, like, if I had to call out a framework of thinking, I think what you would do is you can break that whole journey of building intelligent steps, intelligent machines into like four or five building blocks. There would be these explicit input signals which you get in the context of various kind of setups. For example, in a e-commerce setup, this would be your data which comes from the user behavior on the app. Right? So that's what we refer to as an explicit input, right? The next building block would be, there are a lot of, especially in a business context, there's a lot of implicit, unobserved data, right? And that's what adds to the challenge, right? For example, nobody tells us what is the user's willingness to pay. The user will never tell. So there's this latent signals or implicit signals, which we call. So that's the second building block. And then we are trying to kind of, using these signals, try to estimate his user's price sensitivity or his fashion taste, or in a weather setup, maybe you would say, is there a weather event going to happen? Is thunderstorm going to hit? So using explicit signals, having trying to model this latent implicit signals, can I estimate? So there's a parameter estimation module. Once you're done that, then you're trying to get into the decision making systems, right? What are you really going with these parameters? How can I make better decisions? Right. So then the last second layer is more about decision making, right? In the context of, say, again, a marketplace, e-commerce setup, the decision is how much discount to give to a user, and the objective would be to kind of improve my gross margin. Whereas in the weather context, it would be, yeah, I know a weather event is going to hit. Can I preemptively cancel my flights or preemptively delay my flights? And what is the objective? The objective is passenger impact, right? Minimize my passenger impact. And maybe in a marketplace kind of a recommendation setting, can I predict the rest? Can I show him the best item so that he clicks to drive my conversions? So when one way you can think, there is the framework in which how you define this, how you approach the whole problem. There is a parameter estimation module which looks at explicit signals and implicit signals, and then there is a decision making module. And you might do it in chunks, do them separately, or you can also do end to end kind of modules as well.
Yeah. Now, as someone who is privy to data, right, and who looks at data all day long, what are some wackiest insights that you have uncovered? What are some, one or two nuggets that you discovered and went, wow, I mean, I didn't expect that. This goes against whatever intuitively normally we think.
I think one comes up in from a Myntra perspective, right? I keep thinking like AI or data science is in some sense, although it's a amplifier, it amplifies both the good and the bad. Half of the time we spend is in unbiasing the data. There's a lot of data we have, but some of them can be originated from noisy setups, right? So we spend a lot of time in debiasing the data, removing the noise, right? So coming back to your question, I think this is just about when we're trying to understand fashion sensibilities of a user, and we're looking at these, we have these profiles of different users, right? And how, what does fashion sense, and you look at the age demography and you try to correlate some of that. It was interesting that we were getting that in a certain age group, if you're to like college going students who typically would want to buy more casual, less formal kind of attire, there'll be spikes where they look at, they'll be open to kind of buying a leather bag or a formal attire, and you'd be wondering why you would do that. And when you do the research, you say that maybe they have an interview next, right? So they're just transitioning from a college going into a professional, and there is a change point which you're able to capture. And so the question is, how do you use this insight to drive, say, a personalization event, right? We know the price point of formal wear is a little higher. And so to drive this, do you want to send them a coupon, especially for the first time purchaser? Do you roll out a coupon which drives that change point, which in the long term is favorable for the platform, right? That's the first thing which comes to my mind.
No, very interesting. So today you're the chief scientist at BlackBuck, and I think it's a super interesting business. Calling it the Ola of trucking, as some people do, I mean, does a great disservice to actually the scope of problems that you solve way beyond just aggregating demand and supply on a platform, right? Which itself is a non-trivial problem. So talk to us briefly about BlackBuck and how the platform has sort of evolved over the last few years.
Sure. Firstly, it's, as I said, it's a kind of a homecoming for me back to transportation. I think we were, as I said, transportation has been a kind of a pioneer in adoption of applied math and algos in general. So that just a pointer there. But let me come back to what we do, right? So maybe logistics, obviously is a fundamental backbone to the economy, right? We drive a lot of the GDP, right? And there's a lot of economical movement which is driven by trucking in the Indian context and in general the global context. Having said that, there are a lot of challenges in this environment. For example, how do you predict whether a truck has finished loading? There's a lot of volatility in this. There's a lot of volatility in demand, pricing. Typically, in the offline setup, there is a lot of idling time for the fleet owners. So, the two primary agents in this marketplace which you're building, there's the supply side, we have the fleet owners who are truckers, who have trucks and you want to keep their trucks utilized. So, utilization in some sense is their primary objective, right? Every hour a truck is sitting idle, he's kind of losing, it's hurt, hits its P&L. On the other side, you have the shippers who wants to move a good from A to B. And we are trying to do a matchmaking between these two entities, right? That's one of the businesses we are in. There is a fleet management business as well, which tries to make the life of an FO more efficient. Think of it as a vertical e-commerce. We're giving them, offering them GPS, telematics services, fuel cards, and so on and so forth, insurance and financial services, and so on and so forth. So those are the two main businesses, and a lot of tech is required to kind of serve this, right? Both from a engineering, scalability, high scalability systems, as well as a lot of sophisticated ML algorithms. So let me just pick with say matchmaking, right? So as I said, what we're trying to do, you can think of it as we are offering matchmaking as a service. It's a two-sided marketplace, and if a supplier or a demand puts a load and he wants trucks, right, to move the load from A to B. On the other hand, you have fleet owners who wants to keep their truck utilized and wants to keep them moving from A to B. And the problem at hand is, can I show the right load to the trucker at the right time, right? And by right time, there is a precedence to this setup, right? In typical e-commerce, is matchmaking, right, happening, right? But here there's a spatio-temporal aspect, right? The truck is constantly moving, so I need to know exactly where he is. Has he finished his current delivery? Has he finished loading and unloading? And as I said, this is loading and unloading in the trucking context is quite volatile. It can take anywhere between 3, 6, 9 hours, right? So we need to kind of estimate, is he about to finish his delivery? And if he's about to finish, what could be his typical routes he typically takes, looking at his historical affinity to loads, affinity to areas he typically travels, to the product, to the body type, and so on and so forth, and recommend him the right load, right, at the right time. That's really what I'm trying to do. To the shipper, I'm showing the right trucker, and to the trucker, I'm showing the right load. So that's one fundamental problem which you're trying to kind of solve, right? And as I said, there's a lot of, you can think, one way to think about is there is enough precedence to this matchmaking. It's a kind of a bread and butter of most machine learning teams, right, across any of the tech organization. Like recommendation, personalization, search, ranking. Those are classical ML problems which teams solve, and that's what we're doing. But having said that, there's tremendous amount of customization and kind of domain intelligence which we go in, right? How we, in our context, how do we remove the noise in the data? How do you kind of circumvent some of these volatility? Those are the specific challenges which we try to kind of address using ML algorithms. There is also this understanding of location intelligence, because as I said, we have GPS devices on our trucks and they stream data. We have petabytes of data coming in every week from all of our GPS enabled trucks, right? But then there isn't just raw data is of not much use, right? So we spend an enormous amount of time encoding meaning to those streams, the GPS trajectory, right? We kind of figure out what is a trip, right? Has he finished unloading? Has he finished loading? And then can I delimit the trajectory into trips? I'd figure out his most popular trips or most frequent trips and so on and so forth. So there's a location intelligence module, there is a matchmaking module, pricing module is there, because I think eventually it's still early stages, but at some point, we want to get into pricing in more depth. I think those are some examples.
Right. You alluded to this briefly, but this process of converting data into insights, it's a very complex process, right? First of all, the availability of data itself is skewed, right? I mean, like you folks are perhaps using sensors or something else to get this data and then really reducing the noise from that, then perhaps enriching it and then, encoding it and making meaning out of this. It's a very complicated process. Now, if you were to explain this to a very layperson, right, with no background of data science or tech, can you briefly describe, what is that process from converting data to insights?
I think to begin with, even before you get into the pipeline of machine learning and data science, I think the first and foremost is like the whole digitization journey, right, which the product and the end goes through. You have to pretty much digitize the whole offline process into an online system. So then that's a precursor to doing. The second bit is the data richness of things, right? When you go about building a product, I think you have to be very kind of conscious about the quality, the richness of the data which comes into the platform, right? And I think as product managers and engineers, we kind of spend a lot of time just thinking about that. We want to make sure that the comprehensive data is coming into a system. Second bit is, I think what you need is like data systems, right? We want exact data systems, right? So there is proper instrumentation of the platform, of the product, and the systems are exact in some sense, right? So the data exactness is one of the precursor, right? And then you're going about building these algorithms, right? What are the data constructs, right? How well are you aligning it into the business? And this is the area where probably the actual raw data to transforming raw data to insight happens. And there are a couple of thought processes. One is you really need to understand the business domain. You need to really align your data abstractions, data constructs along the business domain so that you're able to get those insights, right? So part of the insight generation is because you understand the nuances of the business, right? Like the personalization example I was giving you, or how do you decode some of that requires you to deeply understand the business. That entails aligning these data constructs along those. Then there is an algorithmic ML algo development, and then you're talking about measuring. I think measuring systems and making sure your insights are actually play out the hypothesis which you have kind of conceived, they actually play out in reality. So you need experimentation platforms and so on and so forth, right? So yeah, that's probably the journey in some sense of building up of the maturity of a data product.
Right. So knowing the business or the domain is extremely important, right? Because as you mentioned, it's applied mathematics, right? So, and I think, it's important for you to talk to end users and so on as well, right? So, for instance, at BlackBuck, I'm sure that, you would be talking to, let's say, your shippers or fleet operators and so on, right? So, what is that process of like completing the loop, right? Between having a hypothesis, designing an algorithm to do something and then talking to your end users and then realizing that, hey, perhaps, I mean, it works this other way and then going and course correcting. Can you give like a few examples of your interactions with these folks and some kind of aha moments that you've had in conversation with them?
I think the multiple kind of angles to this, right? There's obviously the product folks kind of doing proper user research and the user acceptance testing and so on and so forth, user experience testing and so on and so forth. From a purely data science perspective, I think I would love to kind of stick to the data driven hypothesis making, right? And how do you prove it out? And I think it starts with obviously having worked in different domains, you kind of anticipate what are typical patterns or typical hypotheses, but ultimately you have to kind of prove it via data, right, via experimentation. And I think the kind of the approach we typically take is large scale experimentation, right? We have to have like a proper experimentation platform where we try out multiple hypotheses at a very fast pace, right? Because running experiments are costly, so how do you do it efficiently, right? And that's what we try to do, right? run large scale experimentation, prove out multiple hypotheses on the platform, look at the conversion metric, right? Ultimately, when you do user research, you can probably talk to 100 guys, right? But we can run experiments on 20K users, 50K users. In a day, you'll get what is working, what is not. So I probably are more inclined. Having said that, obviously, in the early part of hypothesis building, there's some amount of user research, there's some amount of market visit where you go along with the product folks, figure out what are the kind of anecdotal questions which come up and some insights which come up which kind of drive your hypothesis building, right? But once hypothesis building, I think you typically rely more on your experimentation platform, running out different experiments parallelly and really figure out at scale, does this insight hold, right? Does this insight lift my conversion metric? And I think that's probably the way as a data scientist we are kind of trained to do.
Right. So if I understand it correctly, maybe the product team does the user research, comes up with a bunch of stories, anecdotes that have to be validated, and then you run experiments at scale to validate these and perhaps give that signal back to these folks saying that, hey, I mean, X, Y, or Z things, and why don't you just like close the loop on those things, right? I mean, that's how it works. So, Deepak, a lot of founders who are listening to this might be thinking that, they want a Deepak of their own, right? I mean, they want a data science function of their own. What is your advice for startups who are looking to build a data science function? And more importantly, when is it relevant? Because again, it's a journey, right? I mean, you mentioned digitization and so on and so forth. It's not relevant to every stage of the startup. So yeah, your advice on how to build a data science function for a startup and when it is relevant.
I think it's kind of definitely the right maturity is required, right? Of the org is very much is critical, right? It has to be the right stage where you think as a company we are ready to invest in, because it could go either ways, right? And I think it's in some sense it's critical to get a somebody who understands the data science domain, and maybe to bring the leader in first, right? Even if he doesn't have a team, because he'll be able to kind of help understand where are we in with that stage, right? And as I said, there are a lot of prereqs, right? Having a good data platform, having a good experimentation platform, the richness of the data, all of that probably is best place to evaluate. I think from a success perspective, I think the two, I would say, have two advices, right? One is, I think we need to sharply define the problem. That's the first thing, right? It's okay to have one or two, but obviously critical business impactful problems, let's just define them sharply, and you define that with the CEO, with the business champions. Let's just define that. That's the first step, right? Can you define these tangible business problems, right? The second is you should set them for autonomy, right? They should be able to kind of be autonomous function, right? Where they understand, once they understood the business problem, they're able to kind of experiment on their own, deploy on their own, and actually see the impact. So I think those are the two critical kind of successes. Like most often, that either the problems are not sharply defined, that might lead to a failure, or complete autonomy doesn't exist, and there is a lot of handholding and transfer of things where things break down. Right? I think those two are fundamental. Other than what I said before, is the data rich enough, other data systems there in place. Those would be my advice.
Right. Yeah, I think tying it to business outcomes and ROI is super important, right? But in this market, hiring engineers is hard enough, but hiring data science folks is almost impossible. What do you do in that case, And even if you do hire them, I mean, there's that process of enablement as well, right? I mean, hiring someone, like a senior leader to kind of define the scope and the problem and everything. So, what is your advice to hire and enable data science folks? And how do you set up that culture of data within the organization?
From a culture perspective, I think probably things have matured a lot. Like if you had asked me this question maybe 4 years back when I was just starting Myntra, or even like 5 years back, I would definitely say that in general, data-driven decision making has become kind of the norm, right? Even in business functions, you have business analysts. So I think we have crossed a certain stage where in general, the maturity of data in an org is probably 3x, 4x where it used to be 6 years back. So I would say we are in a better position, right? From a hiring perspective, really, I think obviously there is a demand supply imbalance. I think, as I said, if you stick to in your interviewing process, there's skills and there is the general aptitude about mathematical kind of, and I kind of summarize it into two things. Right? There's the whole mathematical abstraction and there is the programming. Right? If you can just evaluate on those, the rest he can pick up. A data scientist can pick up with if there's a senior leader, he can kind of take that up. So I would say hiring, you can bridge some of the gaps just if you are able to kind of evaluate on these two dimensions, right? Programming and mathematical formation, that will take care of that. From a setup, as I said, this if you can adopt this whole framework of data exactness, data richness, data constructs, align them along with business dimension, having measurement, AB platform, experimentation platform, I think those would help you to kind of ensure that it's a success for the team. And autonomy and all of those points that we made about it. Yeah, that would probably be the recipe.
So how do you work with the engineering team? How do you overlap with the engineering team, or do you overlap more with the product team? I mean, how does that work? Like how?
I think, especially at BlackBuck, I think it's a very cohesive kind of a equation between the product, the engineering, and the ML, right? And I think it's probably like an ideal setup where we know what exactly the role each plays, right? And as I said, it has matured. So that again, as we mature, all of these problems which you would probably see 6 years back or 5 years have kind of has become less, right? And so it's a very cohesive kind of an equation between the three entities, and we go kind of work very closely with both, with the product and the engineering, right? With the product to understand these hypotheses which they've come up with, kind of validate with them. Then once we do, and most of the ML team are full stack ML engineers, so they do kind of deploy their production. They're kind of building production ready code and work very closely with the engineering team to deploy these ML models, right? So I think with the evolution of ML ops has matured compared to how it was 3 6 years. I think things are becoming more easier and better. And I would say, the equation is quite cohesive and quite kind of very clear as who does what, right?
Right. Yeah, it's good that, on that front, we have come a long way, right? So, hey, Deepak, this was a fascinating conversation. Certainly very interesting for me. I mean, I haven't had a data scientist on the podcast earlier. Again, I mean, a lot of rabbit holes to go down, I mean, to do my reading and to consume stuff and perhaps get back to you with more questions. Before we kind of leave you, right, what are some books or podcasts or resources that you would recommend for someone who just wants to get started on understanding data science, or maybe, if there's a founder who wants to understand the potential of data science or data in general, right? What are a few of these that you would recommend?
I think maybe it's just to kind of get a insight into it. Maybe we can start off with some like very like Nate Silver's book. I think that's a good start to get into how he employed it during the presidential elections. I think that's a good one to kind of get going into it. If you want to just see video kind of playlists, a lot of good playlists around. There are a lot of good podcasts as well. And from classical books, obviously, I can refer classical books, but I will probably not do that. Probably not the right audience here. But yeah, that's probably some of the places where you can start off with.
All right. So we will link Deepak's LinkedIn and Twitter and social handles in the description, and you can definitely follow him and reach out to him as well in case you have any questions. So thank you again, Deepak. Thank you for being so generous with your time. This was a lot of fun.
Thanks, Roshan. It's a pleasure.
If you enjoyed this podcast, consider subscribing and leaving a review on your favorite platform. Also, get updates delivered straight to your WhatsApp inbox by clicking on the link in the description.